Okay, so this is 2025 Higher Level Maths Leaving Cert Paper 1, question 7a. Spiders build webs out of silk. This question involves two different models of how a spider might build its web. The functions in each model gives length in centimeters. In the first model, the web is made in stages. First, the spider makes stage 1 of the web. It then adds extra silk to stage 1 to make stage 2 of the web, and so on. The table below shows the values of Sn, the total length of silk in each stage in the first 3 stages of this model. The table also shows A of n for n greater than 1. A of n is the length of extra silk needed to make stage n from stage n minus 1. A of 1 is set to be 15.8, and that's in centimeters. Use the values in the table to show that A2 is equal to 22 and find the value of A3. Write the values of A of 2 and A of 3 in the table above. Show that A of 2 is equal to 22. Find the value of A of 3. Okay, so in order to find this value here, this is the extra length of silk. What we need to do is take the total length of silk in stage 2 and subtract the total length of silk in stage 1. So it's just simply a case of taking 37.8, subtract 15.8, and that gives you 22 centimeters. So 22 would go in here. Do the same for A3. So you take 66 centimeters, you subtract 37.8, and you get 28.2. So 28.2 centimeters would go in there. And that's it for part 1. Okay, let's look at part 2. The numbers A of 1, A of 2, and A of 3 form an arithmetic sequence. Find an expression in n for A of n where n is natural. Okay, so we have from our tables Tn is equal to A plus n minus 1 times d. That's the formula we use for an arithmetic sequence to find any particular term. So what we've got here is 15.8, then we've got 22, and then we've got 28.2 from the table. If you look at the first difference, you can see that we're adding 6.2 plus 6.2 each time. So all we've got to do is put that into our formula here. So our A of n is going to be equal to A, the first term, which is 15.8, plus n minus 1 times the first difference, which is 6.2. Let's just multiply that out. So you've got 15.8 plus 6.2 n minus 6.2. So our A of n then finally is 15.8 minus 6.2. That's 9.6 plus 6.2 n. So this here is our answer. This is an expression in n for A of n where n is natural. Okay, let's look at part 3. Hence or otherwise find the value of A100. So we want A100. So our formula was 9.6 plus 6.2n. So it's 9.6 plus 6.2 times 100. When you do that, you get 629.6 centimeters. Okay, next part then. Sn is the total length of silk needed to make stage n of the web, where n is a natural number. By using the formula for the sum of an arithmetic series, or otherwise show that Sn is equal to 3.1n squared plus 12.7n. So our formula for the sum of an arithmetic sequence is Sn is equal to n over 2 times twice A plus n minus 1 times d. So we have n over 2 times twice the first term, which was 15.8, plus n minus 1 times the first difference, which was 6.2. So this is our formula here. So presumably when we mess around with this, we will end up with this thing here. Okay, so we have n over 2 times twice 15.8 is 31.6 plus 6.2 n minus 6.2. So we have n over 2 times 31.6 minus 6.2 is 25.4 plus 6.2n. That's equal to, let's see, we've got to divide by 2 and multiply by n. So when you do that, you get 12.7 times n plus, again, we've got to divide by 2 multiplied by n. So that's 3.1 n squared. So we do end up with Sn is equal to 3.1 n squared plus 12.7 n. I think that's what we were required to find. Yeah, 3.1 n squared plus 12.7 n. Okay, let's look at part 5. Stage K is the first stage for which the total length of silk is more than 10 meters in this model. Using the expression for S of n above, solve the equation to find the value of K. Remember that S of n gives the total length of silk in centimeters. Okay, so we have 10 meters here, so we're going to have to change that to centimeters. So let's take our formula, 3.1 K squared, just replacing the n with the K here, plus 12.7 K, I'm going to say is equal to 1000. This here is the total length of silk required to make stage K of the web. And I'm going to let it equal to 1000 or 10 meters first of all. So we've just got to solve this. So let's bring that 1000 over to the other side first. So it's 3.1 K squared plus 12.7 K minus 1000 equals 0. What I'm going to do next is just get rid of those decimals. So I'm going to multiply by 10. Okay, so the next thing I'm going to do is use the quadratic formula to solve this. So A is 31, B is 127, and C is minus 10,000. So we have K here is going to be equal to minus B, so it's minus 127, plus or minus the square root of B squared, so it's 127 squared minus 4 times A, which is 31, times C, which is minus 10,000. All of this is over twice A, which is 31. So this is equal to minus 127 plus or minus the square root of something over 62. Now when you do all of this here, you get 1256129. So remember, the minus minus here is plus. You need to square this and add the answers. So that's going to give us two answers. So the two answers are 16.0285 and so on, or minus 20.125 and so on. We can ignore the negative answer. We can't have a negative number of patterns, if you like. So I'm going to ignore that one. So we have stage 16 plus part of another stage plus part of stage 17. So it's actually during stage 17. It's during stage 17 where the total length of silk will be more than 10 meters. So our answer then, is just K will be equal to stage 17. Okay, let's move on to part B. In the second model, the web is made in laps. The diagram on the right shows the first lap in the web. The line segments marked O1, O2 and O3 in the diagram are the first three orbitals of the web. The lengths of the orbitals of the web form a geometric sequence. The length of O1 is 0.5 and the length of O2 is 0.53. Find the length of O3. So we know that this is a geometric sequence. So we know that O1 is 0.5, orbital 2 is 0.53. So that would just mean that the common ratio then is 0.53 divided by 0.5. When you do that, you get 1.06. So this is our common ratio here. This is what we need to multiply each term by to get the next term. So that would just mean then that O3 is equal to 0.53 multiplied by 1.06, and that is 0.5618. So O3 here would be 0.5618. 8. This is our answer here. And this is in centimeters. You've got to write down the units in these questions or you will lose a mark very often. Okay, next question then. Write an expression for n, the total length of the first n orbitals of the web, where n is natural. So we're talking about the sum of a geometric sequence. So that is Sn is equal to a times, now I'm going to put the r first because it's bigger than 1. So it's r to the power of n minus 1 divided by r minus 1. Doesn't really matter, but generally if the r is greater than 1 you'd put it here, and if it is less than 1 you'll put it out here. Okay, so let's put in our values. So our values are a, the first term was 0.5, our r is 1.06, which we've got to raise to the power of n, subtract 1, and then on the bottom we've got our r, which is 1.06, got to subtract 1. So that's just 0.5 divided by 0.06 times 1.06 to the power of n minus 1. And if you divide 0.06 into 0.5, well, it'll just simplify on your calculator to 25 over 3 times 1.06 to the power of n minus 1. So this is our sum of a geometric sequence. It's the total length of the first n orbitals in the web. Okay, next one then, last part. There are exactly 18 orbitals in each lap of the web. Write an expression in k for the total length of the first k laps where k is natural. Okay, so if we have 18 orbitals in each lap, then for k laps there will be 18k orbitals in the first k laps. So really all we've got to do is take our formula from the previous section. So we have to find the sum of this many orbitals. So in other words, 18k orbitals. So that's just simply equal to 25 over 3 times 1.06. So this is replaced our n. So this is going to be 18k to the power of 18k up there. Subtract 1. And this is really our expression in k for the total length of the first k laps.